Welcome to helpyourmath.com. In this video, we're going to look at examples of simplifying rational exponents. And just to take a sneak peek at this, what we're going to do is we're going to be seeing things like a to the m over n. And what I suggest doing for these is splitting up that exponent and rewriting it or thinking about it as a to the 1 over n, which would be the nth root of a, and then raising it to the power of m. You could hypothetically do this in the reverse order, but then you'd be dealing with bigger numbers, and nobody wants to do that. So my suggestion is take that nth root first, because these should all turn out that they are perfect n perfect powers of n. And then you can apply the property of exponent with that, whatever the numerator is. So for example, we have 16 to the 3/4. I'm going to take that exponent of 3/4 and I'm going to say, well, let's think about this as 16 to the 1/4, which is the 4th root of 16, and then we're going to cube it, right? Because this is now power to a power. If we wanted to combine them, we would get back to that 3/4. Well, the 4th root of 16, the number that would be x times x times x times x equals 16, is 2. So this, inside the parentheses, would become 2, and then we still need to cube it. 2 cubed is 8. So if we're going to simplify 16 to the 3/4, the result is 8. In our next example, we want to simplify 32 to the negative 2/5. So in this case, we're going to have to deal with that negative eventually. We can put it off, or you can do it the first thing if you want. It doesn't really matter. I might just put it with the 2. So when I think about this, I'm going to rewrite it as 32 to the 1/5, and then I'm going to put that negative with the 2 and say, okay, to the negative 2. Now this is saying the 5th root of 32. So again, that's like what number, when I raise it to the 5th power, equals 32? That would be 2. So now we have 2 to the negative 2. The negative exponent tells me I need the reciprocal of the base. The reciprocal of 2 is a half. And then I still need to square it, and we would end up with 1/4. So if we're going to simplify 32 to the negative 2/5, the result will be 1/4. And we want to be careful here. I'm looking at the way that this is written. I use something called equation editor in Microsoft, and it kind of looks like 32 minus 2/5. So we want to be really careful with the context here. Because this is talking about rational exponents, I know that I'm not just subtracting 2/5 from 32, that this is in fact 32 to the negative 2/5. And sometimes what instructors might do is they might not use the proper way to write the fraction. They might write it like this. Let's not change the problem though. Just to really emphasize that that is the exponent, because that is clearly more an exponent than when we see it written like this. Okay, a few more examples. 4g to the negative 6th to the negative 3/2. So again, first thing I would do, however you want to do this, I would work with that 1/2 first. So 4g to the negative 6 to the 1/2, and then all of this is going to be raised to the negative 3rd. At some point, we do have to deal with this g to the negative 6th. If you want to go ahead and turn it, take the reciprocal of g to the negative 6 or g to the 6th, that's fine. That would be 4 over g to the 6th, but it's still raised to the 1/2, and that whole thing is still raised to the negative 3rd. Now it's saying we want the square root of 4 over g to the 6th. The square root of 4 is 2. The square root of g to the 6th would be g cubed, right? This is like power to a power. That's 6 over 2. And now we are raising everything to the negative 3rd. So the negative is saying we want the reciprocal. The reciprocal is going to turn this upside down. G cubed over 2. And then we're going to cube the numerator, would be g to the, I'm going to put it up here, g to the 9th. And the denominator, 2 cubed, is 8. So our simplified answer, g to the 9th over 8. In what I believe to be our last example, it is. We have negative 27, x to the 9th times y to the negative 15th. All of this is being raised to the negative 4/3. All right, so we have negative 27 x to the 9th. Oh, you know what? I'm going to take that y to the 15th and turn it into the denominator. Y to the 15th, that'll just turn it positive. We're going to raise this all to the 1/3, or take the 3rd root, and then we'll raise everything to the negative 4. So the 3rd root of negative 27 is negative 3. The 3rd root of x to the 9th would be x to the 3rd. And the 3rd root of y to the 15th would be y to the 5th. Now we're going to take all of this and raise it to the power of 4. Negative 3 to the 4th power, that's negative 3 times negative 3 times negative 3 times negative 3, that's positive 81. X cubed to the 4th would be x, oh wait, hold up here. We have a negative exponent, so I want to undo that negative exponent, or actually perform that negative exponent by taking the reciprocal of the base. That'd be y to the 5th over negative 3x cubed Okay, now it's just to the 4th. Okay, now we're going to raise everything to the 4th power. That would be y to the 20th over, now negative 3 to the 4th would be positive 81, because that's negative 3 times negative 3 times negative 3 times negative 3. And x cubed to the 4th is x to the 12th. And there we have it.